Okay, this is going to be an introduction to your notes for the day. I went over this in class with everybody, but I just had to make you guys a video just to let you know how this works. I wanted you to get this and not miss it because I wasn't here. So I just videoed just a quick little video of me talking about what we're learning today, introducing it basically. Okay, so we have talked about the words rate of change, but we mostly talk about words rate of change with graphs that go through 0. So we're going to start working with graphs that don't always go through 0, trying to find the rate of change. It's a little bit different, still works the same way-ish, but is just a little bit different to where I have to teach you the certain way to do it. So first of all, these graphs are kind of telling a story. For instance, this one says when the altitude, that means how tall you are in the mountains, when your altitude gets higher, your temperature is decreasing, which is why we see snow on the top of mountains. And then this story over here says driving distance from St. Louis times an hour. So it looks like they're really far away from St. Louis, which is a city. And as they drive, as time goes on, they get closer and closer and closer. That's why the distance is becoming less and less and less. So it looks like these rate of changes are going to be negative rate of changes because they're going down. Whenever we read graphs, we read them from left to right, just like a sentence or a word. Okay? If you're reading it the opposite way, you will read the graph wrong. Because to me, this line is going down, which means I have a negative rate of change. It's going down. If I had a positive rate of change, that means it would be going up, and it would look like that. So for now, I'm going to talk about how to find the exact number for that rate of change. So what I'm going to do is I'm going to take these dots right here. I'm kind of just going to find that pattern, kind of looking at each kind of change. So remember, we used to just kind of be able to count from here and just go figure out where the line was, but it's going to be just a little bit different this time. So if I were trying to find the rate of change, which we are now going to be calling slope. Slope just means rate of change. You might have heard the word slope in real life before just because it is a real word that we use a lot. Slope tells you how steep a line is, and these lines are pretty much going down, okay? So that's what we're trying to find is the number for the slope. So if I were taking, and what you're going to need always for slope is 2 points, and luckily they give us the 2 points, and they even give us the coordinates for them so we can see the values that we're going to be trying to figure out from. Because this graph right here doesn't really connect through the graph perfectly at all. And what I mean by going through the graph perfectly is at these little crosshairs, at these little crosshairs, does the line ever go through one perfectly? And it actually doesn't. So what they did was they gave us coordinates themselves, and it makes it a little bit easier for us. So the way we do this is we go find the change in the up and down, or the change in the y values, so this value over here. And we're going to divide it by the change in these values, the x values, which is kind of like we used to do, which was we did y divided by x, which technically is still the same thing here, but it's going to look a little different. So I'm going to draw a little arrow down and divide it by a little arrow going to the side because that's which way this line is going. So let's figure out how much it was going down and to the side, and whenever I do that, make a little perfect right triangle like that, I am going to be able to figure out my slope. It's going to be a division problem. So if I start here, which is at 0.59, and I work my way down here to 733.8, that means I went from 59 to 33.8 in these numbers here. 59, so let's find the difference between them, which is 59 minus 33.8, which is 25.2, and I am going to put a negative since it's going down. And then we're going to go over. Kind of remember the bottom one is the change in the x values, but I just drew a little arrow to show that I'm going that way. It went from 0 to 7, which is nice because I could have looked at my actual x values in the coordinate, which means it goes 7 units, basically 7 feet. And I take these numbers and I divide them, and it gives me negative 3.6. This number here is my answer. It is my slope. So my slope is going down by 3.6 every time it kind of moved one space. All right, let's look at this one. This one is a little bit nicer because it does have some dots that perfectly go through the graph, the coordinate plane. All right, so if I'm taking these dots and I'm trying to find the pattern through them, I want you to go ahead and draw the nice little stair steps that it makes in the lines. from the coordinate graph. All right, this is going to be our change in y values, which is the down, and then our change in x values, which is the side. And they all are the same, which is why it creates a straight line. And we're going to take those values and try to figure them out. So first it went down from 360 to 240, which if we subtracted goes down 120. So I'm going to put down 120. You could have also seen from 240 to 120, that's going down 120 also. And from 120 to 0, it's going down 120 also. So all of these, no matter which little stair step you chose, it was going down 120. When you move to the side, it looks like it's going over from the 0 to the 2, okay? Or over from the 2 to the 4, or over from the 4 to the 6. Either way, it's moving to the side too. So negative 20 divided by 2 is negative 60, and we just found our slope of this line. And again, this is rate of change. Remember, this is rate of change. So this rate of change tells me, if I were talking about miles per hour, they're going 60 miles per hour. That's a rate of change. But for us, we are going to consider it our slope of the line. All right, that is it for the introduction to the notes. You can move on to the actual slope notes now.